Welcome everyone to a full-on trigonometry lesson here. We've gone through the comic and we've gotten a brief introduction. Now let's take a look at the primary trigonometric ratios and how to use these. Primary trigonometric ratios means sine, cosine, and tangent. Okay? So what are they? The Pythagorean Theorem is what we were using, and that's a relationship between the sides of the right-angled triangles. Okay, and so just to recall, the Pythagorean Theorem is a squared equals b squared plus c squared. Okay, and that's in a triangle that looks like this, where we have a right angle there. Here's our a, here's our b, and here's our c. This side is always called the hypotenuse. And these two, well, they're going to change names depending on whether we're looking at this angle or that angle. Okay. The angle sum property, which we reviewed yesterday, is that all of these angles will sum to 180. 180 is going to be equal to angle A plus angle B plus angle C. And we usually name the corners of the triangle opposite their sides. So that would be angle A, angle C, and angle B. Okay. And so these angles all add together to 180. But we can also relate angles and sides together, and that's what the idea of trigonometry is. Trigonometric is just an adjective that means has to do with trigonometry. Okay? So, first of all, we need to be able to remember how to label a triangle. In this case, this is called the angle of interest. That's the angle that we're looking at the triangle from. Okay, so you'll recall in the question we just did, this angle was 40 degrees, and we knew this was 24. Once I tell you this angle is 40 degrees, this side is opposite the angle. This side is adjacent to the angle. It's like your neighbors that live on either side of you are adjacent to you, and the neighbor that lives across the street is opposite you. And the hypotenuse, well, it's always the longest side of the triangle. Okay, so this is how we label our triangles. Now, it's important to note that sometimes you're going to get triangles that are rotated all over the place. So let me show you what we might be talking about there. So if I have a triangle that's like this, I can still do trigonometry with this. Let's say I'm looking at this triangle. Clearly, that upper left angle is the right angle. This would still be the hypotenuse. But then if I told you that this angle was 60 degrees, which side, we'll call that side A, and this side B, okay, which side would be the adjacent to this angle? You have mics, you can shout it out. Which side is adjacent to this angle, the A or the B?
The A.
Great, so this is the adjacent. And this one, we're not going to call it B, we're going to call that the opposite. And there we go. How do we get Miles back on here? And then, oh man, he's logged out. Yeah. Oh, and then Mom's here. Okay, give me one moment, everyone. Thank you for your patience. Give me the computer, Dad. Okay, sorry about that, everyone. Let's carry on. So let's keep going. So yes, so you just need to be able to rotate these triangles and always see that the relationship is created by the angle of interest. That determines what's the opposite and what's the adjacent. If I drew a triangle that was like this, and this is the 90-degree angle, here's the hypotenuse, and this one was 30 degrees. Here's the opposite, here's the adjacent, here's the hypotenuse. Just need to be aware of that. All right, so we've covered that, so let's keep going. Now, the primary trigonometric ratios relate to all of these different things. And we can use the idea of Sohcahtoa, which is a kind of thing that you can stick into your brain by listening to the songs I've suggested you listen to remember which one is which. Okay? So sine relates opposite to hypotenuse. if we're looking at this triangle here, and I told you that this side was 12 long and this angle was 30 degrees, you could say, and I asked you to find x, okay? You would see that this is the opposite, this is the hypotenuse, and sine would be the trigonometric ratio that relates those. I happen to know that the sine of 30 degrees is 1/2. That means this is going to be as half as long as that. Okay, so this is what the algebra would look like if I write that out. So if I write that out, it's going to be like this. Sine 30 is equal to the opposite over the hypotenuse. Well, I can substitute those in because I know them. Well, the opposite is x, and the hypotenuse is 12. And when I punch this on my calculator, it tells me that's 1/2. Okay? To solve for x, I can multiply both sides by 12. Okay? And that cancels the 12s. And 12 divided by 2, well, that's 6. 6 would be equal to x. So that would be how I could use this trigonometric ratio to solve for x. Okay. And now let's keep going. So, I don't want to talk about the way they remember Sohcahtoa. I should have edited that out of this PowerPoint. It's from another teacher. Anyway, just remember Sohcahtoa. You're gonna hear me say Sohcahtoa bajillions of times, and you're gonna listen to some songs that help you remember. So, if we have this triangle, we should verify that this triangle is indeed a 90-degree triangle. Okay, and the way we do that is use Pythagorean Theorem. If 3 squared plus 4 squared indeed equals 5 squared, then we have a right angle triangle. Then this is true. Okay, this is 9 plus 16 equals 25. That is true. So therefore, this is, yes, that's true. That is a right angle triangle. So if we're looking from this angle here, A, so if I want to know sine A, well, what I do is I say, well, the opposite to A is 3, and the hypotenuse is 5. So sine A would be 3 over 5. That is what it is. Cosine of A, well, cosine relates adjacent to hypotenuse, so that's 4 over 5. And then tangent is Sohcahtoa, T-O-A. Tangent is opposite over adjacent. So opposite over adjacent, tangent is 3 over 4. Okay? Sine, cosine, tangent, they look a little scary when you're first learning them. There's all of a sudden lots more letters. But they're just numbers, people. They're just numbers. So you can just punch them on your calculator and it will just give you a number. Sine and cosine will always be 1 or less, and tangent could be any number. Okay. Now, looking from angle B, okay, if we look from angle B, we'll find that sine, cosine, and tangent are different. Okay. Sine B would be opposite over adjacent. I look across, opposite over adjacent. So, S-O-H. Opposite over adjacent. So that's 4 over 5. Someone's coming in. Let's go admit them to the meeting. And there we go. Admit. Hello, Eva. And then cosine of B, well, I'm looking from this side. Go away. So that's adjacent over hypotenuse. So that will be 3 over 5. Notice that if I look from one angle or the other angle, the sine and the cosine flip. They're kind of opposites of one another. And then tangent, well, that's opposite over adjacent, so that's 4 over 3. And so that's just the reciprocal of looking at tangent from the other side. Now, let's keep going. The practice problems, you're going to do those. So now, let's look at how we can solve for unknown sides. Here is a question. If I know that this is 15 and I desire this measure for some reason, okay? What I'm going to do is I'm going to say, well, I know this angle here, 30 degrees. This should really have a 90-degree sign on it. Otherwise, we can't use trigonometry. Actually, we will be stuck. But so that's 90 degrees. Now I can use trigonometry. I only use these primary trigonometric ratios in this way with 90-degree triangles. Now, what I do is I notice this is the opposite side to that angle. Okay, so I'm looking for the trigonometric ratio that relates opposite with the longest side, which is the hypotenuse. So sine is opposite over hypotenuse. Got it. Okay, so we're going to use sine. We say sine 30 is equal to x over 15. And now I'm going to do some inverse operations to isolate x. I'm going to multiply both sides by 15. These will cancel. And then I multiply this by 15 as well. So this is what I can punch on my calculator. 15 multiplied by sine 30. All right. When I do that, sine 30, I've already told you, it's 1/2. Let me prove it to you. Boop, here's the calculator. Here is the number 30. And here is me taking the sine of 30. Oh, it's 1/2, 0.5. Okay. So this is just a number. I just punched it on my calculator, and I get 15 times 1/2 is equal to x. 15 times a half? Why, that's 7.5, Mr. Jennings. Great, you're right. So 7.5 equals x. Write it on here. And another thing you can do is say, does that look reasonable? In this case, this being 7.5 long and this being 15 long looks totally reasonable to me. If I kind of fold this down and it makes a kind of circle there, it's going to kind of hit there. And that, I guess, is 7.5 here and 7.5 over there. It wasn't a perfect circle that I drew, but maybe it comes in about there, and then it would be cutting that line in half. Or maybe this diagram is not to scale. All right, let's take a look at another problem. Here, I know this angle, I know this, and I don't know that. I want to know this hypotenuse. If I knew this, I could use Pythagorean Theorem, but I don't. I don't know that. So what I'm looking for is, again, that ratio that relates the opposite side to the hypotenuse. It's still sine. Okay, so I write sine 20 equals opposite over hypotenuse. Oh man, I got my unknown as the bottom. Darn. So here, what I'm going to do is just a couple more inverse operations before I go ahead and solve. I'm going to multiply both sides by x. And then I'm going to get another line here. Someone has a question, I'll be right there to answer you. I'll get a line that looks like this. X sine 20 is equal to 10. Okay? But I don't care what x times sine 20 is. I care what x is. So now I go ahead and divide both sides by sine 20. Remember, the sine of 20 is just a number. So I can do that. This cancels this, and I'm left with the last line. This is what I can punch on my calculator. X equals 10 divided by the sine of angle 20. So let's evaluate that. First, let's find the sine of 20. So I can say, I can write the number 20 here, and I can say, take the sine of that number, please. And it tells me that that number is 0.342, blah, 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 blah. Let's take a look at what that means in the context of this problem. This is going to be 3.4 as long as that. Like if this was 100, this would be 34. So I hope that makes sense. This is much longer than this when this is only 20 degrees. All right, so now we know that. We have that number. And now what we're going to do is we can just put that into memory there. And I can say, let's say 10 divided by what I have that number, 10 divided by sine 20, going to give me 29.2. Okay, great. Does that look reasonable? The x would be equal to 29.2. Yeah, that feels reasonable. It's about 3 times as long as this. A little bit less than 3 times as long as that side. Feels right. Okay, I had a few bubblings from the chat, so let's go see what people's questions are. Johnny, you have a question?
Yeah, originally it was why like you put x before sin or whatever, or like sine, but now it's just like the entire question. I have no clue.
Oh, okay. All right. So let me talk through it again. Isaiah, is that roughly the same as your question?
No, I didn't understand why you just didn't solve for the hypotenuse for like Pythagorean theorem.
Okay, yeah, so I can tackle both questions at the same time. So here, the reason I can't use Pythagorean theorem is because I don't know this side. Call it y. If I knew that side, then I could do it, right? But if I set up my Pythagorean theorem, what I would have is x squared equals 10 squared plus y squared. And I'm looking, I only have one equation and two unknowns, so it's not solvable. But when I know this angle, then I can use my trigonometry, okay? And I'll talk through it again for Johnny. So if I look over here, there, I'm going to actually do it right there. Okay, that's going to be good. Where did my writing tools go? Oh man, where did my writing tools? I'm going to open it up again. Distance learning. Everyone's learning in distance learning. There we go. There's my drawing tools. Pin this. Unpin toolbar? No, do not unpin the toolbar. So when I set this up, Johnny, I'm looking for a ratio that relates opposite and hypotenuse, and that's still sine. So I know that the sine of 20 degrees is going to be equal to 10 divided by x. The reason is this is the opposite, this is the hypotenuse, so this is going to be opposite over hypotenuse. Now, the problem, Johnny, is that I have my unknown on the bottom, so it's trickier to solve. If like we recall that sine 20 was, let me move my face way out of the way. The sine 20, here I write 20, and then I take the sine of that. It's 0.3420. Okay, so let's take that number. 3420. That's a pretty accurate approximation of sine 20. 0.3420 is equal to 10 divided by x. Okay, this is an equation that if I solve it for x, I will know this value, x, right? Now to solve that, what I'm going to need to do is isolate x. I want x equals something. To get that, what I'm going to do is I am going to do some inverse operations. First, I move x to the top. And one way I can do that is by multiplying both sides by the unknown, by x. So that's going to be x times what I have on the top on both sides. That way, this x cancels that x on this side of the equation. And now I have a new equation. X times 0.3420 is equal to 10. Now to solve that, because I'm multiplying here, what I'm going to do is divide both sides by 0.3420. Okay, so then, wait, let me do that in another line. So I get this new line, right? And it's x times 0.3420 is equal to 10. Divide both sides by this number, 0.3420, but divide it on both sides. And that will isolate this side. This cancels that, right? These two things cancel. And that gives me x is equal to 10 divided by that, which we found was about 29. Johnny, is that clear now?
Yeah, that makes like much more sense.
Cool, great.
Yeah,
okay, so I'll
thank
continue on this one because I have my tools here. And so let's keep going. Now, we're not always using sine. Sometimes you got to use cosine. Oh, here's an example where you have to use cosine. So here, I know this angle 20 degrees. I know this side 10. And it's actually, you'll notice the same triangle we had here. Now we're just solving down there. Okay, so here, oh, this is not cosine. We need tangent here. All right, so here I notice that this is the opposite side to the angle. And this is the adjacent side. It's right next to the angle. And we're not using the hypotenuse here at all. So if I want to solve this question, what I'm going to use is, well, I think Sohcahtoa. And when I start my test or when I'm writing a quiz, maybe I write down so, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and toa, tangent is opposite over adjacent. Okay, here's opposite, here's adjacent. So that's the one I want, tangent. So I write down tangent of 20 degrees is equal to 10 divided by x, opposite over adjacent, right? 10 over x. Now I use the same type of You can think of it as cross-multiplying. Actually, cross-multiplying is exactly what we're doing. If this was over 1, right? Then you could cross-multiply. But I don't think of it as cross-multiplying. Here, multiply both sides by x. That will move x to the top of the equation instead of having it on the bottom where it's annoying. And this cancels this. So then I have a new line, and it's, I could write it in either order. X times tan 20 degrees is equal to 10. Okay, now divide both sides by tan 20. Notice up here, Johnny, I had evaluated sine 20 here and wrote down a decimal approximation, and then I divided both sides by that decimal approximation. It's the same thing if I don't approximate and I just go ahead and I divide first by tan 20. Divide both sides by tan 20. This tan 20 cancels that tan 20, and it will give me x is equal to 10 divided by tan 20. All right? So,
well, and sorry, why did that time you use 10? You didn't like find out 10, 20 before?
Like you can do it in either order.
So it doesn't matter?
Well, tan 20 is a number, and that number is its number, right? So whether I calculate it over here or whether I calculate it up here, it doesn't make a difference to where those numbers are going to land in my calculator to get to the final answer. Okay, so now I would calculate that, and I would say here, I can just write in 10 divided by, and I have to do this, I'm going to do this in brackets because I'm still kind of confused about my calculator here. The tan of 20, the tan of 20, it says is 0.36, okay? And that makes sense to me. So I'm going to close this bracket. I'm going to say equals, and there's my answer, 27.4. All right, let's go ahead and check and see if that looks reasonable. 27.4 here. Well, 10 is much shorter than 27.4, and I expect this side to be much longer than that side. We also found that this side over here was about 29. So if this side is 29, this side is 10, and this side is 27, that feels really correct. Feels really correct to me. So great, that must work. Now I heard some blinks, so let's go check on people's questions. What are your questions, everyone? Who has their hands up? No one? Anyone have any questions at this point? Ellis, what's your question?
Can you explain again how you figured out it was tan?
Oh, okay, great. Yeah, so sine, cosine, and tan relate three different pairs of sides, right? And so if I go up here, it reminds us. Where is it? Well, up here. There we go. Oh, I hate that. Okay, here. So we have here looking from angle A, the side's the opposite, and sine relates opposite to hypotenuse. But tan relates opposite to adjacent, and it puts them in this order. So when I tackle this question, I notice this is the opposite to this side, and this is the adjacent. I know that tangent relates opposite to adjacent because Sohcahtoa. So tan is opposite over adjacent. And then that's why I write down tan 20 is equal to 10 divided by x. To solve for that unknown, I move it up there and then divide by tan 20. More questions on this stuff? Anyone else?
Yeah, sorry, it's one quick thing, sorry.
No, it's great.
Where'd you get 27.4 from? Like, did you just divide 10 over 10, 20?
Can you read that there? See, 10 divided by tangent of 20 equals 27.4.
And that's how you got it?
Yep. Now, you're all learning all this stuff, and it was one thing to be able to do it right on paper. It's another thing to get it right in your calculator. That's why a key step always is to have a good diagram that's at least like roughly to scale. I wouldn't like this diagram, for example, that says this is a right angle and this is 80 degrees. Okay, that's clearly not 80 degrees, and that doesn't help me with my estimates. So what would be better is if I had, say, I'm going to just create a new problem and then solve it. Okay, let's say I have this side, this here, and that there. That could be 80 degrees. Might actually be closer to 70, but whatever. And then this is close enough to a right angle. And if I said that was 10, what's this length here? Okay. Now, I'm going to look at this angle and I say this is the adjacent and this is the hypotenuse. The hypotenuse is the side that does not touch the right angle. It's always the longest side. So the ratio that relates adjacent to hypotenuse is cosine. So there I will have cosine of 80 degrees is equal to 10 over x. And then when I solve this, it's going to give me x is equal to 10 over cosine 80. Notice I skipped writing down all of my inverse operations. I multiplied both sides by x and I divided both sides by cosine 80. If you give me this as your second line, I'm totally satisfied that you know this goes to the bottom and this goes to the top. Then this is what you punch on your calculator, 10 divided by cosine 80. So when I do that, and before I do that, make a guess. If this is 10, I expect this to be very, very long. I expect it to be something like 45 or 70 or something like that, really, really long. So let's take a look at what it is. 10 divided by bracket, and then I put 80 in here and I say take the cosine of that. And it says this is cosine 80, so now I push equals 57.5. Well, my guess was really useful there, you see, because my guess allows me to validate what my calculator told me. If I wrote down here 0.17, you would say that can't be right because this can't be shorter than that. That's not correct. Okay. But if you wrote down 50, what was it? 57? 57.5, so 58. Okay. If you wrote down 58 equals x, then you would say, yeah, that could clearly be about nearly 60 if that was 10, and this was a very steep angle. Okay, so that's the value of having some of these guesses. All right, everybody. So thanks for hanging with me for this live lesson. And also thanks to my parents that are here and helping out with my kids in their distance learning. They should have shift changed during the lesson, so I have to go catch up with them. But yeah, I will also be closing this video now. So hit me up with your questions in the chat or by email.